So this section we're looking at adding polynomials. We'll do subtraction in the next section. I want to just kind of start by trying to prove a point that if you have 3x and you have 2x, you have a total of how many x's? Bummer. If you have 3 of them and you add 2 more to it, you have 5, right? So it's kind of like you could look at x as though it's an object. So I should have picked maybe something like A and B. So if you have 3 apples, so say x stands for apples. If you have 3 apples, you add 2 more apples to it. You agree you could say you have 5 apples? Where maybe we'll say, I don't know if this is worth messing up your notes, but I'll make this an A and then this a B. But if you have 3 apples and 2 bananas, can you add them together and say you have 5 apples or 5 bananas or 5 apples or bananas? It doesn't make sense. So you can't combine 3A plus 2B. Those just can't be combined together. Or you could I get rid of just that? Not really. But yes, I did. So 3x plus 2, in the same way this first clump has 3 x's. The second one is just the number 2. Can we combine these two? No. So we can't combine. Or you could, if you wanted to, just say equals 3x plus 2, but that's really no different. So this 3x and 2x over here on the left, when we have this here, we call them like terms. I'm going to put it in red for dramatic emphasis, like terms. And when we have like terms, basically they have the same variable to the same power. So same variable to the same power. And that's why, by that definition, you can't combine the 3x plus 2, because this has an x to the first power, and this doesn't have an x to the first. It doesn't have an x, so you can't combine them. Good? Which then is my next line. Only like terms can be combined. And when you get questions like this and they're going to say simplify this, what they mean by that is they mean, okay, we have 4 clumps. We have this 2, we have this plus 8x, we have this minus 4x squared, we have this plus 3x. When something's simplified, 2 things have to be true about it. 1, all the like terms have been combined. So any of those 4 clumps that you can combine together, you do that. The second thing is we have to write it from like the biggest exponent, so this x squared, down to like no exponent. So when we look at this, first of all, can we combine this 2 and anything else?
No.
Nope. Can we combine this plus 8x and anything else?
Yes.
Yes, with the plus 3x. So those are both an x to the first, right? So I'll maybe do it in 2 steps. I'm going to just say the 2. Well, I'm just going to copy that down. My plus 8x plus 3x gives me positive, how many x's?
11.
Nice, 11x. Because I have 8 of them. I add 3 more to that, which gets me up 8 to 9, 10, 11 of the x's. And then last but not least, I have this minus 4x squared. And we can't combine that with anything else, right? There's no other x squareds. So we have this, which is now in the exact opposite order that we want to write it. So we have to write it with the largest exponent first. So we have to take this whole chunk. That minus goes with the 4x squared.
So it's negative 4x squared.
Yep, so it starts out negative 4x squared. You guys with me there? Yep. That minus kind of sticks with it. It's a negative 4 of the x squareds.
So
and then next we have x to the first, so we'd have plus 11x.
Biggest exponent has to be written first, right?
Biggest exponent first. And then plus 2 or minus 2? Plus 2, because if there's no sign written in front of it, we can assume it's a positive 2. So we get a plus 2. Seem doable? Cool. This next one, example 2, sometimes when you see questions like this, they'll have parentheses around them. So they'll say, hey, look, I have this 3-part thing in front. Later on in life, you'll learn that's a trinomial. I have this 3-part thing here. We want to add these 2 together. Typically, they're going to be given to you like this, at least later on in life when you get to the hard ones. So where they do biggest exponent first, then next, and so on until there's no exponents. But when we have the parentheses there, the parentheses don't matter with addition. We'll find out tomorrow with subtraction it does. So you really could just kind of get rid of those parentheses. And how many x squareds total do I have?
2.
I have 2 there. I have 3 there for a total of 5x squared. Everybody a believer?
Mm-hmm.
And then x to the first. I have positive 9 of them here, and I'm adding a negative 3. Positive 9 plus a negative 3, same as positive 9 minus 3. Yep, so I get a positive 6, so plus 6x. And then last but not least, I have a negative 5 plus positive 4, negative 1. Yep. So minus 1. So final answer, 5x squared plus 6x minus 1. Yes? And then very last one, find the total area. So if you were to have like numbers on the side, like here, instead of just being like 3 and 7, you know, it's like, oh, this is a x plus 2 and this is a 2x plus 5, you know. Then when you multiply them together, you'll get an answer kind of like that. So that's kind of what it's coming from eventually. But we just do the same thing here. I have this many x squareds. I have this many more x squareds for a total of how many x squareds? It's a little tricky. It's not 6, 7. Nice. Because if we had to put a number right there in front of this x squared,
It'd be 1.
it would be a 1. Agree? If it's a 1, we don't have to write it in. So it's really saying, if we're trying to find the total area, we have 6x squared plus the 1x squared for a total of 7x squared. And then I have positive 7x's plus 2 more of them gives me plus 9x. And then we have a plus 2 and then kind of like nothing, right? There's nothing over on the right. There's no number without an exponent or without a variable. So we just have a plus 2. And that would be our final answer. So that's really kind of the gist of the notes. If you get stuck with those in the homework, let me know. But I think you'll figure it out.